Okay, today we are going to be finding the roots and the turning point of a quadratic. From factored form of the quadratic, we can find the three coordinates that would be needed to graph the parabola. Remember a parabola, you have an x and y axis. Parabola looks like this, could be concave up or concave down, which means it opens up or opens down. You need the 3 points, the two roots, okay, where the graph crosses the x-axis are known as the x-intercepts, or zeros of a function, and the turning point, okay, the turning point, and these are the roots. Okay, so today from factored form of a quadratic, we are going to find the two roots and the turning point. So there are 3 steps. Step number 1, you're going to use the zero product property to find the roots of the function. So we want the first x value and the second x value. And to do so, we're going to split up the factors and set each individual one equal to 0, then solve for the value of x, the x value of the root. So for step 1, we are going to take the factored forms and basically split them up and set each one equal to 0. So the first one is 3 equals 0, x minus 3 equals 0, and x plus 9 equal to 0. Now notice here we have 3 equals 0. We know that 3 does not equal 0. There's no x value to solve here, so this factor will be disregarded. It's not a root. It was just a greatest common factor that was pulled out of the quadratic. So we're going to solve the next two one-step equations, which we are going to add 3 on both sides. For the x minus 3 equals 0, the 3's cancel, we're left with x equals 3. So our first root, we found our x value is 3, and we know that any point that crosses the x-axis, on the x-axis, we have our x value, but y is 0 at that point, because here's our y-axis. And here, so x is 3, y is 0. When we solve for the next equation, we're going to subtract 9 from both sides. We get x is equal to 0 minus 9 is negative 9. So our second root is negative 9, comma 0. So far, out of our 3 coordinates that we need, we have our first coordinate and we have our second coordinate. We just have to find the turning point now. So that brings us to step 2 and step 3. Step 2 is to find the midpoint, which we're finding the x value of our turning point. And we are going to add the 2 x values from our roots. We need to identify our roots before we do the turning point, and then divide that sum by 2. So for our x value, we are going to take 3 and 9, add them, 3 and negative 9, excuse me, add them up and divide by 2. So x equals 3 plus negative 9 is negative 6. Divide that by 2 and we get negative 3. So x equals negative 3. So far for our turning point, we have negative 3. I was right about that, negative 3. And we just need to find our y value. And we do so by then plugging in the midpoint, the x value, into the quadratic, in our case, the factored form of the quadratic. And this will be the turning point, the y value of your turning point. And remember, the turning point is also called the vertex. So step 3 would be taking this x value, right, and plugging it back in to your f of x, which is f of negative 3 now. So wherever you see a x, you're going to put negative 3 into your equation right here, your factored form of the equation in this case. And then we're going to go ahead and solve. Remember, f of x is the same thing as stating y, so we are finding our y value here. And according to PEMDAS, we do what's inside parentheses first. So negative, we're going to bring down this 3. Negative 3 minus 3 is negative 6. Negative 3 plus 9 is positive 6. And now we multiply. So negative 3 times negative 6 is negative 18 times positive 6, which is negative 108. So our turning point is negative 3, comma, negative, not 180, negative 108. Okay, so that is how we utilize our 3 steps to find our 3 coordinates needed to graph a parabola.